Hopefully, everybody is doing well and enjoying this very informative session today. And what I wanted to really talk about is an area that is of very much of passion for InfoVista. What we really thrive on is trying to better understand how do we drive most out of the networks as they stand today, especially in this event, in this pandemic times and the times of crisis. When you think about, in the old time, we used to say that oil is like the new gold. That's what they were saying in the 80s and 90s. And now, of course, oil has negative value in the marketplace. And when you think about what is the real gold now, it's really bandwidth. And especially as people are looking at new connectivity models, and they're looking at really, and the networks themselves are getting very challenging. The networks are getting very fragmented, they're getting very disaggregated. And what everybody's trying to figure out, especially in this new connectivity model where people are looking to connect from home to the cloud, how do you make the most out of the networks? So we are very passionate about it. We are very passionate about 5G, the implications of 5G. We are very passionate about looking at narrowband IoT and massive IoT sensors that are coming into the networks, and how do we drive majority of the bandwidth to drive mission critical applications. Now let's talk about automotive, right? What are we seeing is the number one challenge, right? We've had some major car manufacturers in Europe who have embraced the technology. We have also worked within the standards bodies. We have been looking at connected car for a while now, and also we've been working with auto parts manufacturers too, right? OEM guys who are getting embedded onto the instrumentation of the car. And the number one thing that comes up again and again is like I said, fluctuation in connectivity. Right? Things work sometimes, things don't work sometimes, but there's so much mission critical stuff that's happening inside the car. The car is becoming a life critical entity. So if there's a lag, that can actually cause a fairly significant harm. So we got to make sure, how do we ensure the QoE is there all the time, and how can you predict it, and how do you manage the fluctuations in the network? So predictive connectivity, this is exactly what we've been talking about, right? This is an example of an individual that is traversing a path going from point A to point B, and we want to be able to go ahead and say, okay, the network that's coming up, is it giving you the right signal to noise ratio? Is it going to be usable or not usable? So we want to be able to do a look ahead as the individual is traveling and predict the quality of the network so that their application experience can be adapted in real time. Right? And if they need alternate route decisions, we can also even do that, right? We can look at all the different mechanisms and give them the best experience possible. And if there is a bad patch coming up, we tend to either buffer up or we go ahead and say, okay, we change the application performance, application experience to make sure that they can manage their capability through. So this is a very critical part of the puzzle, right? Ability to look ahead, predict ahead, pull that data in so we can make the intelligent decisions now. So from a user perspective, they get a seamless experience. So there are three critical aspects in this journey of delivering predictive QoE and QoS. QoE is quality of experience. QoS is quality of service, right? It's just like UI, user interfaces and user experiences, right? So we look at quality of service is looking at really your jitter, your lag, your packet loss rate. So really those metrics to define what the service needs from the network perspective. quality of experience is really looking at, okay, how does that experience get absorbed, right? Because sometimes some applications are okay to manage jitter or packet loss, right? And can we normalize it at an application level and improve the quality of experience? So here we're talking about collecting data, right? And the best place to collect the data is on the car. It's not in the network. It's on the car. So what we have done is we have created an instrumentation. Thames is our flagship product that we have that we've deployed across the globe to do 5G network testing, 4G testing, 3G testing, really performance validation and performance measurements. So we have now created a lightweight version of Thames. This is very critical. A lightweight version of Thames, and we've deployed that on board inside of cars. This way, that particular, think about almost like a sensor that is collecting data about radio RF measurements. That's what that lightweight version does. It collects all that data and then it pulls it together, and then we use that and analyze and make prediction. And part of that is machine learning. Machine learning, backpropagation algorithms, deep learning becomes at the heart of this whole ML piece. And then we have to drive prediction. So it's connect, analyze, act, right? We collect the data through our onboard technology. Then we analyze it, and we use ML to go ahead and start building predictive models and predictive QE, and then we predict. And this, when we are on board, we can have a full 360-degree view from the vehicle to infrastructure, the network load, resources, O&M measurements. We get a full 360-degree view that we are pulling the data from. And this enables us to really provide a very simple mechanism to do predictive QE. And to do on board, we work with a lot of auto manufacturers. We are working with leading auto parts manufacturers to embed our technology onto their TCU so that we can go ahead and give them that insight. All right, again, just at a high level summary, one of the TCU, which is what I talked about, the telematic control unit, is where we would get embedded into. We have an onboard agent that has a chipset already in place. This is the 5G RF modem chipset that's embedded on our onboard measurement that becomes part of the TCU, which is the telematic control unit of the car, to get embedded over there. And then we have a cloud platform that does the analytics. So this is doing the collect piece, this is doing the analytics piece, and then does a closed loop back on the act. So that's what I wanted to kind of conclude on that particular note. Hopefully that was insightful and useful. Hopefully I didn't get too technical. Sometimes I get too technical because of the network side. But hopefully everybody was able to understand that particular presentation. Thank you very much for the opportunity.